All right, so we are in week 3, day 2. And so put that there to remind you. We're a minute 55. Number 1 says 5,649 rounded to the nearest 10 equals. So when you round to the nearest 10, you look at the place behind it. So if it's bigger than 5 or bigger, you go up. 4 and down, 4 and under, you go down. So this is a 9, so it's going to go up. Well, we'll have to change this to the next place value, which would be 50. So 5,650. If you had 1,000 rounded to the nearest thousands place, you look at the 5 in the thousands place, look at the hundredths place, and say, is it bigger than 5? Yep, so this is going to make this whole thing go up to 6,000. I wish that's how money worked, like my paycheck. No, actually I don't. That would be bad for me. I'd lose money. Never mind, undo that. If both the length and the width of this rectangle, length and width of, the one that's shaded, of this rectangle were doubled. Well, they don't say that. But I'm assuming they mean the shaded one. So if it was doubled, both the length, so it would be over here, double 3 is 6, double 2 is 4. What would the new area be? If the length was doubled and the width was doubled. So we would have a 6 long and 5 wide. So find area, it's length times width, so it'd be 30. We could check. 1, 2, 3, 1. Oh, no, not times 5, sorry, times 4. My bad. Good thing I double checked. 1, 2, 3, 4. 6 times 4 is 24. So 24 altogether. 24 squares. If the length and the width were doubled. Alright, circle the two smallest numbers. Oh, I hate this. So, first of all, smallest means we need nothing more than unless there's something that doesn't have anything in the ones place. So, is there anything that has something in the, so that's a tens place, so that's not going to work. So ones place. So now we're looking for a ones place with no, so this is like $3.68 and this is $3.06. So we want the one that has, we need 2. And this one has a 0 in that space too, but so does this one. So we know we don't need those ones. So now we need 2, we have 3. So this one is 3 and 6 hundredths, and this is 3 and 8 hundredths, and this is 3 and 68 thousandths. But this is definitely smaller than that because this is like still 6 cents. I always cover this up and like remember it's like money. So there's like $3.06, and now this is the matching that one, but now it's $3.06 with 8 parts of a penny. So this and that would be our smallest. Alright, if 7 squared equals 7 times 7, which is equal to 49, then 8 squared is 8 times 8, which is equal to 64. So the square root of 64 equals 8. And this, because these are squares, square root of 49 is 7. Just good to know that, since we've been talking about it. For problems 5 and 6, use the spinners. How many possibilities could occur if both spinners are spun? Well, you can get D1 and D2. So for every one here, there's 2 possibilities. So there's 2 possibilities there. There's 2 possibilities here. There's 2 possibilities there, and there's 2 possibilities there. How many possibilities could occur if both spinners are spun? 2, 4, 6, 8. What is the probability of getting a and then a 2? So you have the chance of getting a, so that's 1/4. There's only 1/4. And then you have a chance of getting a 1 or a 2, right? So you have half the chance. So we would multiply that across. 1 times 1 is 1. And 4 times 2 is 8. You'd have 1/8 of a chance. I always love those games when we play them in class with dice and spinners. It's probably one of my favorite things that we do for math. I love wondering what the odds would be in some of these cases. Just like with our candy, we'll play a game with that next week about probability. Fill in the missing prime numbers between 2 and 30. Huh? Oh, I see. So these are just all prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Can't see my answers very well. For problem 8 through 10, use greater than or equal to, or greater than or less than or equal to. So this is 10, and how many times can 2 go into 20? 10 times. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're equal. This is $2.80. I always put the other number on there, even though this one would actually be this way, because that has a, okay, this is a sign on top. That bar is like the repeating number, and it should let you know that it will go on with sevens forever. So we have $2.80 and $2.77. Obviously, $2.80 is more. Now this one is a little trickier. I have 50 cents, or 50%, 50 cents, whatever you want to call it. And then here we have 2/3. So if I wanted to figure out how much 2/3 would be, I'm going to scoop my paper up, sorry. If I wanted to figure out how big 2/3 would be, I could put numerator inside denominator. Inside, so if I want to divide it, inside or in front for the calculator, if you're going to do it, in front would be in front, inside. So 2, kind of messed that up. Sorry. So I'm going to do my work over here. I have 2 and 3. So can 3 go into 2 evenly? Nope. But it can go, and we'll put your decimal up there. The 3 can go into 20. How many times? 6 for 18. And we're going to subtract and see how much we have left. 20. 3 can't go into that, so we're going to bring a 0 and then bring the 0 down, which will get us another 3. And, or sorry, not a 3. 3 goes into 20 6 times for 18. This is going to go on forever. It will go on. But we did find our answer. We have 66 hundredths, and here we have 50 hundredths. So 66 or 50, which one's bigger? All right, we did it. Nice job.